normally is covered in the tribology course. You may also have other types of bearings, air bearings, or even your maglev, which is based on magnet. So basically, you lift up the contact so that you allow relative movement between two surfaces. But for us, we are interested in roller element bearings. If you look at your construction, you will most likely look like this. This is a cross section. This is your shaft. You have your gears. You will have bearings to support your shaft. So you can see this is the housing. That's your shaft. So you have the bearings between your shaft and your housing. Bearings are required to locate your shaft. Okay, it carries two purposes. One is to carry allow the movement, rapid movement between your shaft and your housing. The other is that you must be able to support the loads. So bearings can support loads in two directions. One is the axial direction, which is along the axis of the shaft. The other is in the radial direction, which is in the radial direction. Some bearings are designed to carry both the axial and the radial load. Some are only for radial load, some are only for the axial load. This is called the truss. If you look at a bearing, what are the major components of a bearing? Basically, you have an outer race and you have an inner race. So the outer race is connected to your housing. Your inner race is connected to your shaft. In this picture, you have the outer race that is connected to your housing, and the inner race is connected to your shaft. Some of them are called outer race, some of them are void. In between the outer race and your inner race, you have your roller elements. So this could be in the form of a cylinder, or this could be in the form of a ball. So basically, these are very general definitions of the components of a bearing. The different types of bearings. Okay, the most common one you will see will be your ball bearing. This allows radial loads, a little bit of the axial load. So this is the most common one. It's also the most, it's also the cheapest one. There are different types of bearings. Your notes are actually added an H. In fact, I realized H is actually this is a typical roller bearing. Okay, you have this kind of ball bearing. You may also have a cylinder as your roller element. So in this case, this is called a cylindrical roller bearing. Then you have variations of ball bearing and the cylindrical roller bearing. So for example, with this, a cylinder is not really a cylinder, but it's a tapered cylinder. Okay, this allows, the reason why we have this is because this is at an angle. And this is at an angle, it allows for load capacity in not just the radial direction, but also in the axial direction. Because the load now in the axial direction, you have a surface that can carry the load. You may have this type, you have what is called a self-aligning bearing. It looks something like this. So if you have any misalignment in your shaft, you can use a self-aligning bearing. Because the inner race can rotate with respect to the outer race. It's the same function with this tapered. This is your spherical roller bearing. Okay, this is called spherical roller bearing because the inner race there looks like it has a curve. So it's like a radius to it. So again, this is similar to that self-aligning ball bearing in the sense that this one can also open for some misalignment. You may also have some angular contact ball bearing. If you look at this, the top surface there is basically directly almost parallel to the bottom surface. With your angular contact ball bearing, you look something like this. Okay, your ball is seated between two surfaces that are diagonal to each other. So similar to your tapered roller bearing, these diagonal contact surfaces allow for some load in the radial direction, but also in the axial direction. So you have any applications which require both radial and axial direction, D and F would be useful. The last category, which is basically can carry axial loads. Basically, you place your shaft on this. Basically, you place your shaft on this. This is the end of your shaft. This one can only carry axial load. In general, which one to choose, whether ball or roller? So ball typically can carry lower load because it's a ball, so you have only a point. You have only a point contact supports. Because it's a ball, it is only a point. Okay, when you contact your wrist. With a roller, basically it's a line contact. So you can imagine a line contact will carry a higher load compared to your point contact. But because it's a point contact, so you can go at a higher speed. The roller bearings typically should go at a lower speed compared to the ball bearings. Talk about the load carrying capacity. So basically your ball bearings will have very good radial load capacity. It has some axial load capacity. If you talk about your cylindrical roller, it has even better radial load capacity because it's a line contact. In terms of axial load capacity, it's actually very poor. It's the same as needle. Needle is basically just a very small cylinder. They use very small cylinders instead of relatively. If you look at these examples, the rollers are quite big. Needle big. For needle rollers, basically these are very small. So like the cylindrical rollers, the radial load capacity is excellent, but your axial load capacity is very low. So you want some form of radial plus axial, you should start with the ball bearing. If the application requires only radial load, then you should be looking at cylindrical rollers. You can see if you talk about the tapered rollers, they can carry both radial and axial loads. Any questions? Okay, let's look at how we install bearings. When you install bearings, we have different considerations. We have to talk about how to combine bearings. And these are basically, if you look at your catalogs, what kind of combinations you can use. How do you mount the bearings, and what kind of lubrication. So what you must remember is that when you assemble your bearings, you need accuracy and dimensioning because you need to prevent the bearings from turning unnecessarily within the housing or your frame. Mating surfaces must be clean, should not have any discontinuities. So when you install bearings, you have two contacts. One is on the shaft, the other is on the housing. And normally we have one contact which is of interference fit, the other is a loose fit, or loose or intermediate fit. Basically, the loose fitting is at the housing. Okay, this is the housing, this is your shaft. You have two contact points between the bearing and your machine. So this one is your contact between the bearing and your shaft. That one is the contact between the housing and your bearing. So the contact between the housing and the bearing should be loose. The contact between your shaft and your bearing should be interference fit. On the shaft, you have two bearings. One is a fixed end, one is not fixed end in the sense that its position is locked. If you look at this end, you see that there's no clearance between the bearing and the frame. So this is your frame, there's no clearance. This one is also, there's a lock here which locks your bearing. The other bearing is free, it's called a free end or a floating bearing. You can see here that there's some clearance between your frame and your bearing. It can move sideways. So this is allowed for any misalignment or for any expansion of the shaft. This is one example from last year's work. You can see here that this shaft can move relative to the frame. And I think this is too much delay already. And if you look at why it can move, I also think that they've done it wrongly because the shaft basically moves relative to the bearing. Rather than the bearing moving relative to the frame, it's the shaft that moves relative to the bearing. Because the interference means the shaft that moves relative to the bearing. The bearing can move relative to the house, the shaft moves relative to the bearing. You can distribute this. So for free end bearings, you can choose. Basically, what you do is you just fit. You just have a clearance fit between your outer ring and your housing to allow some movement. Or basically, you just have a clearance between your outer ring and your housing to allow for some axial movement. If need be, you can also use some kind of bearings that allow your outer race and your inner race to be disassembled. And once you can assemble your inner race to your shaft before you assemble your rollers and your outer race. So this one, some of the cylindrical roller bearings will allow you to pick out the bearings, disassemble the bearings, and then to fit bearings yourself. Otherwise, if you use a ball bearing, basically you just need to make sure that there's a clearance at your housing side. Once installed, if you look at your bearing specifications, once installed, you should really check for some kind of internal clearances in the bearings. Normally, they'll quote you an axial clearance. They'll also quote you a radial clearance, which is what people ball and the race. Most likely, if your contractor is doing this for you, then you don't have to worry about this. Okay, how many of you are familiar with when you see something like this? Talk about tolerances and fits. Those of you who are mechanical engineers have seen this before. Okay, maybe we just go through very quickly. Basically, we have shaft, we have a housing. As I said, there are two contacting surfaces here. One is for your inner race, the other is for your outer race. And you typically see, if you look at the catalogs, you typically see something like this. Okay, you will see a fit to your shaft and a fit to your housing. So basically, what would this mean? Okay, first of all, let's do some simple definitions. Clearance is the gap between two elements. So in this case, if you say there's a clearance between your shaft and your bearing, the clearance is basically the gap between your shaft and the inner race of the bearing. Okay, that is a clearance. There are three types of fits. The first one is called clearance fit. Clearance fit means there's always a gap between the two elements. So if this is your shaft, that is your inner race. Clearance fit means this one does not touch. The two surfaces do not touch. So there's a gap in between. Interference fit at the other end will be that one of the diameter of the shaft will be bigger than the diameter of the hole. So basically, what you imagine here is that this is going to be a very, very tight fit. Once you install it, the shaft will move relative to your inner race. You also have some transition fit where you basically have a mixture of clearance and some interference. This is normally useful for rotation of rotating of parts and not necessarily to fix one element. So you have three fits. If you talk to anybody who's in this area, will normally tell you whether it's an interference fit or clearance fit. So at least you now know what these are. There are also two systems of fits. One is called the hose-based fit. So if you look at something like this, if it's a capital H, then it's a hole-based fit. What does this mean? This means that the hole size is the one that determines all your other dimensions. Basically, what it means is that if that is the hole,